All right, answering one more question in the study guide was, which molecule has more energy? One that is oxidized or one that's reduced? So let's go through this again. Here is NAD. It does carry a positive charge. Remember, that is our electron carrier. However, it does also carry a proton as well. Proton 2. And my analogy with NAD was that truck. So just as a reminder for the whole process. Here is my electron carrier. Here is my hydrogen. Where's the hydrogen coming from? Remember, we are harvesting the hydrogen from that molecule of glucose. So, quick example, here's glucose and glycolysis. That molecule will be split into two, and we will also harvest a couple of hydrogens off of that molecule of glucose from either side, and you will be left with these hydrogens to be loaded onto the electron carrier. So here are these two hydrogens. They have been harvested from glucose. Now, at the end of glycolysis, we will have 2 molecules of pyruvic acid plus 2 molecules of NAD that have been loaded or reduced with that hydrogen. Again, where did the hydrogen come from? The original glucose molecule. All right, this is getting complicated for me to carry everything. We did mention electrons cannot run around the cell freely without causing damage, so they do need to be carefully chaperoned or carried. The electron carrier in our body is NAD. That hydrogen will be loaded onto the electron carrier, and remember, this electron carrier is going to be taking the hydrogen harvest to the electron transport chain so that it can be converted or used to catalyze that ADP plus PI bonding event that ATP synthase catalyzes to produce or synthesize ATP. All right, so we are taking the potential energy. The other analogy I had in class was thinking of that glucose molecule as a big apple tree that's being harvested. So as a tree is going to be harvested for its fruit, glucose is being harvested for its fruit, which will be these hydrogen atoms. So all of these hydrogen atoms are going to be harvested during glycolysis and the Krebs cycle. They will be carried on electron carriers, NAD, and a little will be carried on FAD. And those electron carriers, like I said, will be going to the electron transport chain. All right, so which one has more energy? Would you say an empty truck going to a market is going to make more money, or a truck that is full of the harvest going to the market will make more money? Hopefully, you have said one that has the harvest. And like I said, in this case, NAD is going to be empty or unloaded. That is the oxidized form. Here we have the harvest from glycolysis or the Krebs cycle, 2 hydrogens. Those 2 hydrogens will be loaded onto the electron carrier. The only caveat to that is NAD as a molecule carries 2 electrons and only 1 proton. However, I don't have the capability of separating those protons and electrons according to my models. So just pretend that when you see 2 of those hydrogens, that means there are 2 electrons loaded onto NAD. However, there will be only 1 proton. The other proton does stay soluble in the cytoplasm. All right, so which one would you rather have? Would you rather have a loaded truck to take to market or an unloaded truck? I'm hoping that you are going for your loaded truck. This one would be reduced, and the more protons and electrons you have, the more energy you potentially have. All right, now to relate this to fats. You've probably heard of saturated fats, saturated fats versus unsaturated fats. Well, what are they saturated with? Hydrogen. Does it make sense that more hydrogen equals more energy? equals more calories versus less hydrogen equals less energy and therefore fewer calories. All right, so kind of unite what you already know. Unsaturated fats are better for you because they do have less hydrogen, more double bonds, less hydrogen in that carbon backbone, and they will give rise to fewer calories in energy transformation. All right, on to the next.